Hello students, welcome back to yet another session of chemistry on the topic thermodynamics. In our today's session, we will be discussing some of the important concepts related to the derivations for the work that is being performed in a reversible process and an irreversible process. We will be seeing some numericals, and we will also be focusing on the aspect of the first law of thermodynamics. So without any further delay, let us understand what is the work done in an irreversible process. Now, when we say irreversible process, what exactly do we mean? We mean that this process is going to be a unidirectional process. We mean that this process is going to take place at a high speed. We mean that in this process there are going to be mechanical changes that are taking place, and those changes will be easily identified. Okay, irreversible and reversible process, इसका सबसे बड़ा and सबसे important aspect ये है that irreversible process is easily identifiable. A reversible process is an ideal process. Practically it is not taking place, it's not possible. Okay, ideal process, that's reversible. But irreversible process is a practically possible process, something that we notice in and around us every time we perform any activity in our labs. So here what we are going to see is that, let us say a container, okay, it is containing a certain amount of gas with a pressure P, volume V and temperature T. It's enclosed in a cylinder, what we can see over here on the screen, and what's easily identifiable is that the cylinder is fitted with a piston that's moving up and down, and every time this cylinder moves down, you can see that the gas in it is getting compressed. Okay, so it's a cylinder which is fitted with a weightless, frictionless piston. Okay, and this piston is compressing the gas, and as it's getting compressed, you can see that the molecules are coming closer. You can see that the volume is decreasing. You can also understand that the pressure on the gas is increasing. Now, the cylinder is fitted with a movable, frictionless, rigid piston of area A. Now, as this gas will expand, what will you notice? As the gas will expand, what will you notice? You will notice that the piston will move up. Okay, it will move up, let us say, by a distance d against an external opposing force F, against an external opposing force F. So what we can see over here is that the piston is pushing the gas down. Okay, it's compressing the gas. But let us say that this gas in the cylinder would expand. In that case, what would happen is the gas would push the piston up. वो गैस क्या करता था? वो पिस्टन को ऊपर पुश करता था, एंड जब वो पिस्टन ऊपर मूव होता था तो इट वुड हैव मूव्ड अगेंस्ट एन ऑपोजिंग फोर्स. अगेंस्ट एन ऑपोजिंग फोर्स, वी आइडेंटिफाई दैट फोर्स एज F. The distance by which this gas will move the piston up, we say that this distance is d. Now, the work done in this process is given by the formula opposing force into distance. See, work is performed only against opposition. Let us say the piston is moving, but there is no opposing force. So the piston is moving freely. अगर पिस्टन के ऊपर कोई opposing force ही नहीं है जिसको counteract करके पिस्टन को ऊपर जाना है, so the piston is freely expanding. The piston is freely moving up, the gas is freely expanding, and in that case work is not getting performed. क्यों? Simple reason, opposing force वहां पर नहीं है. There is no opposing force, work is not performed. अब कितना वर्क परफॉर्म हुआ ये किस पे डिपेंड करेगा? How will we identify that? How much is the work getting performed? The work getting performed can be identified by two things: opposing force कितना है, and second, distance कितना move हुआ है. How much distance has by how much distance has the piston moved? Now, in this case, the formula is W is equal to minus F into D. Look at it. F is the opposing force and D is the distance. Okay. Minus sign यहां पर क्यों आया? Why is there a minus sign over here? A simple reason for this is the minus sign indicates what? The minus sign indicates that the work is done against an opposing force. Opposing force का डायरेक्शन क्या है? डाउनवर्ड्स है. पिस्टन किधर मूव हो रहा है? अपवर्ड्स मूव हो रहा है. पिस्टन इज मूविंग अप, ऑपोजिंग फोर्स इज एक्टिंग इन द डाउनवर्ड डायरेक्शन. ऑपोजिंग फोर्स डाउनवर्ड डायरेक्शन, पिस्टन को जाना कहां चाहिए? नीचे. लेकिन गैस पिस्टन को मूव किधर कर रहा है? ऊपर. सो इफ द गैस इज मूविंग द पिस्टन इन द ऑपोजिट डायरेक्शन, okay, we will denote it by a minus sign. Now, work W is equal to F into D, but here there is a minus sign. The negative sign indicates what? That work is done against an external opposing force. And also it is important to understand that the internal energy of the gas, अब piston को ऊपर move करवाने में who is doing the work? Okay, if the piston is moving up in a direction opposite to the direction of the force, force is acting downward, piston is moving upwards, force is acting down, piston is moving up, दोनों का डायरेक्शन ऑपोजिट है, तो पिस्टन को ऊपर मूव करवाने में वर्क कौन कर रहा है? हु इज परफॉर्मिंग द वर्क? द गैस इज परफॉर्मिंग द वर्क. गैस इज परफॉर्मिंग द वर्क ऑफ मूविंग द पिस्टन अप, and that is the reason why we say that it is two opposite directions, and that is the reason why we put a minus sign over there. Now, the force opposing the expansion is constant. Let it be denoted by external pressure, P external. PEX here indicates the external pressure which is applied on the piston. PEX also indicates the external pressure जिसको काउंटरएक्ट करके हमारा गैस एक्सपांड होगा एंड पिस्टन को ऊपर की तरफ मूव करेगा. So PEX into the area of the piston is the force which has to be applied, because the entire piston has to move up. Okay, the entire surface of the piston has to move up. अगर पिस्टन के ऊपर एक uneven force अप्लाई किया गया, अगर पिस्टन के ऊपर एक यूनिफॉर्म फोर्स अप्लाई नहीं हुआ, तो पूरा पिस्टन पूरी तरीके से ऊपर नहीं जाएगा. So the force applied on the piston by the gas in the cylinder has to be uniform across the area. पूरे पिस्टन का जो सरफेस एरिया है उस पे प्रेशर गैस अप्लाई करेगा, जिसके वजह से पूरा पिस्टन ऊपर जाएगा. So the entire piston will move up. So the force that is acting on the piston is given by the pressure external, which the gas will counterfeit and move against, and the area of the piston. So now the expression becomes minus P external into A into D. This area of the piston, A minus F था, तो F के जगह पे क्या आ गया? P external into A, and D is anyways the distance by which the piston is moving up. D is the distance by which the piston is moving up. Now here A into D is the volume covered by the piston in the process of expansion. Okay, P external side में रह गया, A into D एक common factor बन गया है, which is talking about the volume by which the piston is moving up. How much volume has the gas expanded? How much more volume of space is the gas now occupying by moving the piston up? And that change in volume will be given by delta V. The change in volume will be given by delta V. So यहां पर expression क्या हो जाएगा? Minus P external into delta V will be the expression for the work. And what type of work is it? Expansion. It's expansion. Expansion means the gas has expanded. Expansion means the final volume is more than the initial volume. Expansion means the final pressure is less than the initial pressure. Okay, and over here negative sign indicates that it is the work of expansion. Minus sign अगर वहां पर नहीं होगा, okay, if you have the expression as W is equal to P external into delta V, that P external into delta V, you can notice that there is no minus sign. On the last equation of the screen you can see that there is no minus sign because it is the work of compression. अब यहां पर क्या इंपॉर्टेंट पॉइंट है, ध्यान देने वाली बात यह है that in the work of compression the direction in which the piston is moving, okay, and the direction in which work is getting performed is the same. पिस्टन के ऊपर जो एक्सटर्नल प्रेशर एक्ट कर रहा है वो भी डाउनवर्ड डायरेक्शन में है, पिस्टन जो मूव कर रहा है डाउनवर्ड डायरेक्शन में मूव कर रहा है, सो बोथ द थिंग्स आर द सेम, तो वहां पर नेगेटिव साइन नहीं आएगा, देयर विल बी नो नेगेटिव साइन ओवर देयर बिकॉज द डायरेक्शन इन विच द वर्क इज गेटिंग परफॉर्म्ड एंड द डायरेक्शन इन विच द फोर्स इज एक्टिंग. ओके, please understand this thing, direction in which work is getting performed and direction in which the force is acting, both are the same. So when both are same, there will be no negative sign over there. So W will become P external into delta V. So for expansion, negative sign, and for compression, there will be no negative sign. This is about the work done in a irreversible process. Important point to understand over here, the importance of the negative sign. उसका कोई mathematical significance नहीं है. It is only indicating the direction of work performed and the direction of force applied. Okay. Another important thing to understand in irreversible work, that this work gets performed at a very high speed. It moves at a very high speed. Important point to understand in irreversible work, that these kinds of work performed and processes always go to completion. Important point about irreversible work is something that you can notice in your day-to-day life, in your surroundings. That is about irreversible work, which is also known as pressure volume type of work. Now, reason why it's known as a pressure volume type of work, because in this kind of processes, the changes that are taking place in the pressure and the volume are easily identifiable. Okay, they are visibly identified. जो भी changes होंगे pressure and volume में, वो देखकर हमें easily समझ में आएगा that yes, the work is getting performed, and that is why they are also termed as the pressure volume type of work. I hope this is clear to everyone. Anyone having any queries or doubts in this, please put it on the chat box. All right. Now we move ahead to the next aspect. That is the points to remember. The work of expansion is negative. Work of compression is positive. We just saw the equation some time back. कुछ time पहले ही हमने equation देखा. Work of expansion का W is equal to minus P external into delta V. And for compression, it was W is equal to P external into delta V. Now, work not getting performed. Work is not getting performed in case of absence of opposing force. The work is not getting performed in case of absence of opposing force. In expansion, the work is done by the system. Expansion means the piston is moving up. So if the piston is moving up, who is performing the work? The gas in the cylinder is performing the work. So work is done by the system. In the work of compression, work is done on the system. In the work of compression, work is done on the system. If external pressure is 0, then work done is 0. External pressure is 0, work done is 0. Why? Because there is no opposing force. If there is no opposing force, there will be free expansion. If there is free expansion, work is not getting performed. Okay? If the final volume is greater than initial volume, then the work done is the work of expansion, which is negative. So if the final volume is more, work is negative. And if your final volume is less than the initial volume, then the work done is positive. If the final volume is greater than the initial, work done is negative because it's expansion. In expansion, the system is performing the work. And if the final volume is less than the initial volume, then the work done is positive. Okay, the work done is positive, that is the work of compression. I hope these points are clear to everyone. Just have a good look at it before we move ahead. Now, we go to our next concept. Okay, now this is the work done in a reversible process. This is also known as the derivation for maximum work. Okay, this happens to be a lengthy one, and this question can come either for a 3 mark or a 4 mark. Okay, you need to understand over here that work done in a reversible process has much more significance, much more importance than work done in irreversible process. अब आप बोलोगे कि सर रिवर्सिबल प्रोसेस में जो वर्क परफॉर्म हो रहा है इसके डेरिवेशन का इरिवर्सिबल वर्क के डेरिवेशन के कंपैरिजन में इंपॉर्टेंस ज्यादा क्यों है? लेट अस अंडरस्टैंड व्हाई इज दिस important aspect to understand, an important question to be answered, okay, an important concept to be understood well. Reversible process is not a practically visible process. Reversible process हम practically nature में कहीं observe करने वाले नहीं है. We don't come across reversible processes in nature, very first of all. The second important thing is that reversible process के जो terms and conditions हैं वो बहुत ज़्यादा strict and astringent है. Strict and astringent in the sense there are a lot of factors which influence a reversible process. Okay, और क्योंकि ये प्रोसेस हमको नेचुरली विजिबली आइडेंटिफाइड नहीं है, प्रैक्टिकली इसको परफॉर्म करना इजी नहीं है, इसीलिए इसको अंडरस्टैंड करना और ज़्यादा इंपॉर्टेंट हो जाता है. जो प्रैक्टिकली विजिबल है, जो विजिबली आइडेंटिफाइड है, understanding that concept is not difficult. Why is it not difficult? Because it can be performed n number of times. Okay, you can have n number of ways of analyzing it. But in a reversible process where you know that it's not a natural process, it's an artificially man monitored process. Man monitored process means आपको लैब में कंट्रोल्ड कंडीशंस के अंदर ये प्रोसेस परफॉर्म करना पड़ेगा अगर आपको रिवर्सिबल प्रोसेस एंड उसके एस्पेक्ट्स अंडरस्टैंड करने हैं तो. ओके, इसको मैक्सिमम वर्क क्यों बोला जाता है? इसको मैक्सिमम वर्क इसीलिए बोला जाता है बिकॉज इस पूरे कंसेप्ट में कहीं पर भी एनर्जी का लॉस नहीं होता. Okay, when a system is performing work at a high speed, you know, when a system is performing work at a high speed, what happens? One part of the energy is lost in transaction. One part of the energy is lost in transaction. When you say lost in transaction means in the process of performing work, some part of energy is lost. It is not getting converted into work. That energy is getting utilized, but it is not getting converted into work. Okay. अब यहां पर क्या होता है, जो वर्क परफॉर्म करने का स्पीड है वो इतना स्लो है दैट एनर्जी का लॉस होता ही नहीं है. All the energy gets utilized and converted into work performed. Why does the energy utilized and get converted into work performed? Is because of a simple reason that the speed at which the work is getting performed is very slow. It's a very slow process. Okay, it's a non-spontaneous process. It is something which will take place at a very slow rate. So when it takes place at a very slow rate, at a very slow speed, there is no loss of energy. All the energy that gets utilized gets converted into work. Now, we can see over here we have a cylinder with a volume of gas in it, and we can see that the piston is moving on the gas. The piston is moving and it's compressing the gas is expanding, it is moving the piston up. What do we say over here? We say that, let us say that this cylinder now contains an ideal gas. Why do we say an ideal gas over here? Reason very simple, that this is an ideal process, it's not a practical process. आपको ये process easily अपने nature में in and around दिखने वाला नहीं है. So here n moles of an ideal gas is taken into a cylinder. Now this cylinder is fitted with a weightless and a frictionless piston at a constant temperature T. हम किसी भी फैक्टर को चेंज नहीं होने दे रहे हैं जो हमारे गैस के वॉल्यूम या प्रेशर या गैस के किसी भी मेजरेबल क्वांटिटी को अफेक्ट करे. So it's a weightless and a frictionless piston at a constant temperature T. Now let us say that the gas expands from initial volume V1 to final volume V2, and each time this gas expands by a small volume dV. Okay, initial volume V1 है, final volume V2 है. गैस को एक certain limit तक एक्सपांड होकर के आगे जाना है। एंड गैस जब ये एक्सपांशन का वर्क परफॉर्म करेगा तो ये एक्सपांशन के वर्क को छोटे छोटे स्टेप्स में करेगा। ओके, इट विल परफॉर्म द वर्क इन n number of small steps. So each time the gas will expand, it will expand by a small volume, we denote it by dV. Okay, and this dV expansion is against an external pressure P, which is decreasing by a small amount dP and producing a small work dW. तो गैस को एक्सपांड होना है फ्रॉम V1 टू V2. लेट अस अंडरस्टैंड दिस थिंग. गैस को एक्सपांड होना है फ्रॉम V1 टू V2, बट ये V1 टू V2 डायरेक्ट एक सिंगल स्टेप एक्सपांशन नहीं होने वाला. गैस धीरे धीरे पिस्टन को स्टेप बाय स्टेप ऊपर पुश करेगा. नाउ व्हेन द गैस विल स्टेप बाय स्टेप स्लोली मूव द पिस्टन अप, each time what will happen, the gas will do a small work against the opposing force. Opposing force piston को नीचे push कर रहा है, gas को piston को ऊपर push करना है. So when the gas is pushing the piston up, it is opposing the external pressure by a small amount dP. It is performing a small work dW. The volume is changing by a small volume dV. ऐसा n number of times perform होगा. Every time the gas will increase slightly by a small volume dV, it will oppose the external pressure by a small volume dP. It will do a small work dW. And when this repeatedly happens, okay, when this repeatedly happens, what you notice? The total change you notice, the total change that is from V1 to V2. It is like climbing the stairs, okay, you climb a stair one at a time. But when you repeat that process one by one, repeatedly you are climbing the stairs, you will notice that by the time you climb, let us say 50 to 100 stairs, you have moved yourself from the ground floor of a building to the 5th or the 6th floor of the building. So you cannot directly move from the ground floor to the 6th floor. You will climb the stairs one by one. So when you climb a stair once, okay, you are lifting your entire mass, your entire weight of the body by a small distance, okay, against the gravitational force, okay. You are covering a small height h, but you repeat this n number of times. Let us say you repeat it 100 times, you land up on the 5th floor of your building. So this small work of climbing a stair at a time, lifting your body against the gravitational force by a small height dh, and this getting repeated to finally lift you from height 0 to height h. This is what we are trying to explain over here. That when a work is getting performed in n number of small steps, energy is getting conserved, energy is getting only converted into work, there is no loss of energy, and all the work gets converted into, all the energy gets converted into work, and that is why we say that this is maximum work. Now, we all know that pressure external is P minus dP, okay? Pressure external is P minus dP. Okay, now the piston moves up by a small distance dx, and the change in volume is given by dV is equal to A into dx, that is the area of the piston, and dx is the distance by which the piston will move up. dx क्या है? Distance by which the piston will move up. A क्या है? A है उस पिस्टन का पूरा एरिया, क्योंकि पूरे पिस्टन को मूव होना है. अगर पिस्टन के लेफ्ट साइड से या पिस्टन के राइट साइड से सिर्फ प्रेशर अप्लाई होगा तो पिस्टन एक साइड से टिल्ट हो जाएगा, लेकिन ऊपर मूव नहीं होगा. एंड जब तक वो ऊपर पूरी तरीके से मूव नहीं होगा, वी कांट से दैट द गैस हैज एक्सपांडेड. ओके, सो द स्मॉल वर्क इज गिवन बाय dW, which is minus P external into dV. Again over here the small work is performed against opposing force. So when this small work is performed against an opposing force, we will have a negative sign over there. अब P external क्या है? P external is P minus dP. तो हम क्या करेंगे? P external के जगह पर P minus dP सब्स्टिट्यूट कर देंगे. हमारा इक्वेशन क्या हो जा रहा है? माइनस P external into dV becomes minus into bracket P minus dP into dV. अब सिंपल चीज जो हमें करनी है वो ये है कि हमें ब्रैकेट ओपन करना है. ब्रैकेट ओपन करोगे तो क्या होगा? dW इज इक्वल टू माइनस P dV हो जाएगा प्लस dP इंटू dV हो जाएगा, जो आपको यहां पर दिखाई दे रहा है. अब यहां पर दो फैक्टर्स हैं, माइनस P dV विच इज प्रेशर इंटू द चेंज इन वॉल्यूम, द स्मॉल चेंज इन वॉल्यूम dV, एंड एक दूसरा वैल्यू है dP इंटू dV. अब dp क्या है स्टूडेंट्स? dp is the small change in pressure when the gas is expanding by a small distance dx. dp is the small change in pressure. dv is the small change in volume. जब दो स्मॉल क्वांटिटीज को मल्टीप्लाई करेंगे ना तो एक बहुत ही छोटा क्वांटिटी मिलेगा. Okay, when two small quantities are multiplied you get a very small quantity, and when you get a very small quantity you neglect it in chemistry. Okay, so dp into dv is negligibly small and hence it is neglected. This is the best part of chemistry, that negligible quantities and negligible values are neglected. Okay, so all we have is dw is minus p into dv. What we are left with is dw is equal to minus p into dv. अब हमारा जो सिस्टम है वो ये वर्क परफॉर्म करेगा हर स्टेप में. एवरी टाइम द गैस विल एक्सपांड, दिस इज द वर्क विल बी which the gas will perform. Every time the gas expands, this is the work which the gas will perform. ये वो वर्क है जो गैस एक स्टेप में परफॉर्म करता है, एक बार में परफॉर्म करता है, एंड इस स्टेप को रिपीटेडली रिपीट करता है so that you can move the final volume, that is V2. Now what we do is we will integrate this factor, that is the PdV, okay, between the initial P1 V1 to the final P2 V2. We say that the system, okay, it changes from P1 V1 to P2 V2 isothermally and reversibly. Isothermally and reversibly, involving the temperature constant at T. So let us say the initial A is P1 V1 and the final stage B is P2 V2. Now we integrate this small work dW between A and B. A is the initial and B is the final. तो हम नोटिस क्या कर रहे हैं, dW की जगह पे क्या आ गया, माइनस पी dV आ गया. Okay, now PV is equal to nRT. We all know this thing from ideal gas equation. We have done it in states of matter. Okay, वहां पर कुछ laws हमने पढ़े थे, gas laws, Charles law, Boyle's law, Gay-Lussac's law, okay, Avogadro's law, and then we combined all of it to get the understanding of the ideal gas equation, which was PV is equal to nRT. अब यहां पर हमारे पास एक फैक्टर है P, तो P के जगह पर हम क्या लिख सकते हैं, PV is equal to nRT, तो P को हम बोल सकते हैं nRT upon V. Okay, you can see PV is equal to nRT on the screen. अब अगर मैं P को लेफ्ट हैंड साइड ऑफ द इक्वेशन पे ही रहने दूं तो राइट हैंड साइड पे मुझे क्या मिलेगा, nRT upon V मिलेगा. Now instead of substituting P over there, we substitute nRT upon V. Okay, now dV is also a quantity which we are integrating between A and B. तो जब हम dV को इंटीग्रेट कर रहे हैं between A and B, nRT को हम seclude कर देंगे because number of moles R, which is universal gas constant, and T, which is the temperature. These three factors are constant. तो ये तीन factors क्या होंगे, इंटीग्रल साइन के बाहर निकल जाएंगे. कौन चेंज हो रहा है इस इक्वेशन या इस प्रोसेस में, कौन चेंज हो रहा है, वॉल्यूम चेंज हो रहा है, एंड वॉल्यूम इज चेंजिंग फ्रॉम V1 to V2. Okay, and it is changing by n number of steps, multiple number of small steps. Okay, and in each step what is happening, the volume is decreasing by a small factor dV. Yes or no? So this dV upon V is the factor which will get integrated between the initial value V1 and the final value V2. Okay, nRT को हमने बाहर निकाल दिया. Okay, V2 minus V1, and when we introduce log, negativity gets replaced into division, so we have log to the base E of V2 by V1, that is final volume upon initial volume. But log E को solve करना practically possible नहीं है, so we convert it, okay, into the base of 10 by taking a constant factor 2.303. Our equation becomes minus 2.303 nRT log to the base 10 of V2 by V1. Now, at constant pressure, we have studied something called as the Boyle's law. Boyle's law, what does it state? It states that at constant temperature, pressure is inversely proportional to volume. अगर गैस का प्रेशर ज्यादा है तो उसका वॉल्यूम कम होगा, एंड अगर गैस का वॉल्यूम कम है तो उसका प्रेशर ज्यादा रहेगा। करस्पॉन्डिंगली अगर गैस का वॉल्यूम ज्यादा है, प्रेशर कम है, ओके, एंड इन अदर वर्ड्स प्रेशर कम है तो गैस का वॉल्यूम ज्यादा है। So pressure and volume can be equated, okay, in terms of each other by the help of the Boyle's law, which states that at constant pressure, pressure and volume of a gas are inversely proportional to each other. P is inversely proportional to V, that is pressure of a gas is inversely proportional to volume at constant temperature. So यहाँ पर V2 by V1 can be replaced by P1 by P2, P1 by P2. So the same equation will become in terms of pressure minus 2.303 nRT log to the base 10 of P1 upon P2. Okay, so this is the derivation for the work done in a reversible process, which is also known as maximum work. dW over here indicates the small work which the gas is performing at one point of time. dW indicates the small work which the gas is performing at one point of time, and when this work will be performed by the gas repeatedly, what we will come across, what we will notice is maximum work, and the derivation of it is what you can see on the screen. Just quickly go through it, and if there is any question or any query, put it in the chat box. सब लेक्चर्स में All right, let us move ahead. Now, what are the features of a reversible process? Just as we understood the properties or the features of irreversible process, let us understand what are the features of reversible process. It is an extremely slow process. Okay, such processes never go to completion because opposing and driving force will always be present. Opposing force and driving force हमेशा ही present होगा, and because it will always be present, it will never go to completion. आपको ना तो लेफ्ट हैंड साइड पे ना राइट हैंड साइड पे कहीं पर भी आपको 100% या 0% ये वैल्यूज देखने के लिए नहीं मिलेंगे. These processes are ideal in nature. The driving and the opposing force are equal and opposite in nature. In a reversible process, the driving and the opposing force are equal and opposite in nature. The other thing is, such processes are always in a stage of equilibrium. Such processes are always in a stage of equilibrium. The work obtained in a reversible process is maximum work. Work obtained in a reversible process is maximum work. The other thing, that reversible processes are difficult to be performed in practice. Reversible processes are difficult to be performed in practice, and naturally no process is reversible. Nature में exist करने वाला कोई भी process reversible नहीं है. Naturally no process is a reversible process. Okay, so these are the important points or important features related to the reversible process. This can again come as a question for 2 marks. Please have a look at it. Now, moving ahead, we go to the other aspect, that's understanding what do we mean by intensive and extensive properties. Okay, intensive and extensive properties, these are properties of a system. Now, when you use the term intensive, okay, it has to deal with certain quantity, certain factors. Again, extensive also deals with certain quantities and certain factors. Simplest आंसर क्या है इंटेंसिव प्रोसेस का. Okay, intensive process, these are those properties which do not depend upon the mass of the system. They don't depend upon the mass of the system. Okay, now what else can be said? That intensive properties are not additive. Intensive properties are not additive means अगर आपके पास सेम ही सब्सटेंस है जिसका आपके पास दो अलग अलग क्वांटिटीज है, वो क्वांटिटीज को ऐड करने से उनका इंटेंसिव प्रॉपर्टी ऐड अप नहीं हो जाएगा. वो क्वांटिटी को ऐड कर देने से उनका इंटेंसिव प्रॉपर्टी ऐड नहीं हो जाएगा. ओके, द अदर थिंग, एग्जांपल्स ऑफ इंटेंसिव प्रॉपर्टी, बॉइलिंग पॉइंट, मेल्टिंग पॉइंट. ओके, द टेम्परेचर at which a particular substance may melt or evaporate, refractive index, density, pressure, viscosity, okay, temperature, etc. There are a lot of quantities which can be termed as, you know, intensive properties of a substance, जिसका substance के mass, substance के quantity से कोई लेना देना नहीं है. It has nothing to do with the quantity of the substance or the mass of the substance which is involved. Going ahead, what do we mean by extensive properties? Extensive properties, these are those properties of the system which depend upon the mass of the system. These are those properties of the system which depend upon the mass of the system. Extensive properties are additive in nature, means extensive properties can be added up. Examples: heat, volume, mass, enthalpy, amount of substance. Okay, enthalpy and heat over here, these are two important factors which are extensive. बहुत से students इसको they consider it mistakenly as an intensive property, but that's not the case. Enthalpy is the total amount of energy which is present in the system, and total amount of energy which is present in the system उसको हम किससे relate करते हैं? The amount of work performed and the internal energy, the amount of work performed and the internal energy. So work performed and internal energy will be enthalpy, which is an extensive property. Heat and temperature, again a very common thing where a lot of students make mistake. Heat is related to amount of substance. Okay, temperature is not related to amount of substance. You have 500 ml of water, you have 100 ml of water, you have 10 liters of water. Everything is going to boil at 100 degrees Celsius only. 500 ml पानी हो या 5 लीटर पानी हो, उसका बॉइलिंग पॉइंट फिक्स है 100 डिग्री सेल्सियस. सो दैट इज टेम्परेचर. ठीक है, आपके पास आधा किलो बर्फ है या 1 किलो बर्फ है, बर्फ का मेल्टिंग पॉइंट फिक्स है 0 डिग्री सेल्सियस. दैट इज टेम्परेचर. बट हीट, I have a container containing 1 liter water kept on a burner. Okay, I have another container containing 5 liters water which is kept on another container. In which container will I notice evaporation of water taking place first? In which container will we notice the evaporation of water taking place first? We will notice that container 1, which is containing 1 liter water, in that the evaporation will start faster than the container 2, which is containing 5 liters of water. क्यों? 5 liters water को 100 डिग्री सेल्सियस पे पहुंचने के लिए टाइम लग गया. It will require more amount of heat to reach 100 degrees Celsius. 5 liters water is also going to start boiling at 100 only, and 1 liter water is also going to start boiling at 100 only. But 1 liter will reach 100 faster than a 5 liter container. Okay, so this is the difference between heat and temperature. Remember this thing, this comes as a give reason. Okay, point to remember over here is that the ratio of two extensive properties is an intensive property. A very important point. Okay, it also comes in your multiple choice questions. Remember that the ratio of two extensive properties is an intensive property. What next is an example? Density, we all know, is an intensive property. You can also see that density is an example of an intensive property which has been mentioned earlier on the screen. But density का formula क्या है? Density का formula है mass upon volume. Okay, here mass and volume both are what? Both are extensive properties. तो ये एक important point है जो आपको पता होना चाहिए, that the ratio of two extensive properties will always be an intensive property. So over here what we are noticing is that density is an intensive property, but mass and volume are extensive properties. Okay, so that is about intensive and extensive properties. I hope it's clear to everyone. Moving ahead, let us have a look at this numerical, which says that 3 moles of an ideal gas has expanded isothermally. Okay, has expanded isothermally. This is an important point over here. 3 moles of an ideal gas has expanded isothermally. ये ही स्टेटमेंट हमें बताएगा कि इस क्वेश्चन में हमको कौन सा फॉर्मूला यूज करना है. अंडरस्टैंडिंग? वर्क के हमारे पास टोटल 2 फॉर्मूला है, वर्क in terms of irreversible process and work in terms of reversible process. When we say work in terms of irreversible process, we say W is equal to minus P delta V if it is expansion, W is equal to P delta V if it is compression. If it is W max, maximum work, then we say that W max is equal to minus 2.303 nRT log to the base 10 V2 upon V1, or we say that W max is equal to minus 2.303 nRT log to the base 10 of P1 upon P2. These are the formulas. कैसे पता चलेगा कि कौन सा फॉर्मूला सम में यूज करना है? Okay, by looking at the sum, by reading the statement and the information given very carefully. यहां पर एक ही टर्म यूज हुआ है, isothermally. They have not used the term isothermally and reversibly. जब तक आपके क्वेश्चन में रिवर्सिबल ये वर्ड नहीं आता, तब तक आप उस क्वेश्चन में W max का फॉर्मूला नहीं अप्लाई करेंगे. Until and unless you have the term reversible mentioned in your numerical. If the question is saying isothermally and reversibly, forget about isothermally. If it is just saying reversibly also, reversibly ये word आया है तो आपको W max का फॉर्मूला यूज करना है. अगर रिवर्सिबल वर्ड, रिवर्सिबली ये वर्ड नहीं आया है तो आपको W max यूज नहीं करना है. यहां पर हम देख रहे हैं that the gas is expanding isothermally, means at the same temperature. The gas is expanding at the same temperature from volume of 15 liters to 20 liters at constant external pressure of 1.2 bar. Okay, bar is the unit for pressure. Okay, 1 bar is 1 atmosphere. Okay, so you can remember it that way. 1 bar, 1 atmosphere, it's the same. So 1.2 bar or 1.2 atmosphere again would be in the same. We have to calculate the amount of work done in joules. What do we have to calculate? We have to calculate how much is the work performed by the gas when it is expanding from a volume of 15 liters to 20 liters, means it is expanding by a volume of 5 liters. तो यहां पर सम रीड करते ही हमें यह पता चल जाता है that change in volume is 5. Okay, now let us have a look. Initial volume is 15, final volume is 20, external pressure 1.2 bar और 1.2 atmospheres, both mean the same. फॉर्मूला जो यहां पर अप्लाई होगा वो है माइनस पी एक्सटर्नल इंटू डेल्टा वी. वाई माइनस? बिकॉज एक्सपांडेड. अगर कॉम्प्रेस्ड आता तो आप वहां पर फॉर्मूला में माइनस साइन यूज नहीं करते, बट यहां पर एक्सपांडेड आया है, सो वी विल हैव टू यूज द माइनस साइन. नाउ सब्स्टिट्यूटिंग द वैल्यू, प्रेशर एक्सटर्नल की जगह पे 1.2 and delta V is 20 minus 15, that is final minus initial. We get 1.2 into 5, which is 6 liters per bar. This is the work. Now what is important to understand? Negative sign over there indicates that it is work of expansion. Negative sign का कोई mathematical significance नहीं है. Okay. Now 1 liter bar is 100 joules. Remember this conversion fact. 1 liter bar is 100 joules. हमको वर्क हमने ढूंढ तो लिया कितना वर्क परफॉर्म हुआ है, बट वी हैव फाउंड इट आउट इन टर्म्स ऑफ लीटर बार और लीटर एटमॉस्फेयर. लीटर बार बोलो या लीटर एटमॉस्फेयर बोलो, इट मीन्स द सेम, बट 1 liter atmosphere or 1 liter bar is 100 joules. So 6 liter bar will be 600 joules. So the work performed in this case will be 600 joules, and because there is negative sign, work done over here is of expansion. The work done here is of expansion. I hope this is clear to everyone. Have a good look at this numerical. This can come as a question for 2 marks, okay? And here important points are that in this question reversible word is not present, तो W max के लिए यहाँ पर मत सोचना. Expanded दिया हुआ है तो W के सामने माइनस साइन आएगा. W will be minus P external into delta V. Have a look at the question very quickly. Going ahead, let us understand what we mean by the first law of thermodynamics. Okay, in all we have 4 laws of thermodynamics. Okay, now this is the first law what we are going to discuss today. Apart from this, we have the second law of thermodynamics, we have the third law of thermodynamics, and we have the 0th law of thermodynamics. Okay, तो पहले क्या आया? पहले फर्स्ट लॉ आया, फिर आया सेकेंड लॉ, फिर आया थर्ड लॉ, एंड इन तीनों लॉज के बाद आया 0th law of thermodynamics. It is not that the 0th law came first and then the first, second and third. So first to come was the first law, second to come was the second law, third to come was the third law, and the last to come was the 0th law of thermodynamics. Now this first law of thermodynamics, I am sure everyone must be familiar with it. This is also known as the law of conservation of energy. It's also known as the law of conservation of energy. Now what does the first law of thermodynamics state? The first law of thermodynamics, it states that energy can neither be created nor be destroyed. It can only be converted from one form into another, and the total amount of energy in the entire universe remains constant. Okay, so energy can neither be created nor be destroyed. It can only be converted from one form into another form, and the total amount of energy in the entire universe always remains constant. We say that over here, let the initial internal energy of the system, let it be denoted by U1. U is the symbolic representation for internal energy. U is the symbolic representation for internal energy. So U1 is the initial internal energy and U2 is the final internal energy of the system. U2 is the final internal energy of the system. Now this system, let us say the system absorbs heat, which is denoted by Q. The work done on the system is given by W. Work is performed on the system. Heat is absorbed by the system. System ने heat absorb किया and heat absorb करने के बाद भी system के ऊपर ही work perform हुआ. Heat absorb करने के बाद भी system ने work perform नहीं किया है. Work has been performed on the system. So the expression becomes U2 minus U1. Final minus initial. Change in internal energy क्या आ गया? Heat absorb कर लिया plus work भी system के ऊपर ही perform हुआ. So when work is performed on the system, energy of the system is conserved. Energy of the system is conserved. When work is performed by the system, energy is utilized. When work is performed on the system, energy is conserved. So U2 minus U1 becomes Q plus W. Delta U becomes Q plus W, and this happens to be the mathematical expression for the first law of thermodynamics. Is this clear to everybody? The mathematical expression for the first law of thermodynamics, that is delta U is equal to Q plus W. यहां पर कौन सा इंपॉर्टेंट एस्पेक्ट है जो आपको नोटिस करना है? इफ हीट इज रिलीज्ड बाय द सिस्टम, इफ हीट इज रिलीज्ड बाय द सिस्टम तो वो माइनस क्यू हो जाएगा. ओके, इफ वर्क इज डन बाय द सिस्टम तो वो माइनस डब्ल्यू हो जाएगा. करस्पॉन्डिंगली इक्वेशन में भी आप वो ही फैक्टर्स सब्स्टिट्यूट करेंगे. लेट अस से इफ वी वुड हैव सेड हीट इज रिलीज्ड बाय द सिस्टम, it would have been denoted by minus q. So here delta u would be equal to minus q plus w. If we would have said work is done by the system and heat is absorbed by the system, it would have become Q minus W. So what you have to remember, work done on the system is W, work done by the system is minus W. Okay, heat absorbed by the system Q, heat released minus Q. This is the first law of thermodynamics. I hope this is clear to everybody. That was it for our today's session. What we have discussed is the work done in a reversible process, the work done in irreversible process. We have seen the concept of intensive and extensive properties. We have seen the first law of thermodynamics, and we also saw a numerical which gave us an idea about how to identify which formula for work performed has to be utilized. Okay. In our earlier sessions for thermodynamics, we have seen the concept of enthalpy, the derivation for change in enthalpy. We have seen the understanding for the various types of processes. We have understood what are the different types of enthalpies that are related to a system or a process. That is it for our today's session. We'll be continuing ahead in the next session. Thanks a lot.